Everyone. Yeah, very good morning. Shall we begin the session? Today's topic is regular expression, that is session number 11, that is regular expressions and the CS script. So whatsoever the regular expression that is carried out, whatsoever the data that is used, so that data will be available, that data will be used within the database. That a regular expression may be an expression that is available within the database, or that is used within the processing, that is the pre-processing conditions. So these database are the ways to specify the text processing conditions. It is used in a number of the regular expressions programming languages, but it is unfortunately not standardized. It is a central part of the scripting language. That is a part. When we say about the regular expression, that is also this feature also used in the Cold Fusion, that is almost compatible, that is almost used with the Perl 5. And in a Cold Fusion, regular expressions are used in the two basic ways. What are the two basic ways? One is So these two basic ways are used as a searching and the replacing. So first of all, search for the symbols pattern in the string of the symbols and then replace that symbol with the new string symbols or new symbol pattern. So there are two parts in this. One is the searching, one is the replacing. And there are four RE functions that is used in the CFMX. One is the RE find no case, RE replace, and RE replace no case. So these are the four functions, four RE functions that is used in the Cold Fusion, that is used in the CFMX Cold Fusion markup language. Markup extensible language, we can say, because it's the CFMX. Yes, the first two functions are used for searching that is identical with exception that the first in the case is case sensitive and the second is also the case insensitive. One is searching, one is the replacing. And these functions can take up to the 4 arguments, of which only the first 2 arguments are required. First two are required over here, first two are gathering the data over here. And the first required argument is a regular expression containing the condition for identifying a symbol pattern in the text string given as the second required argument. Similarly, for the third and the fourth, third and the fourth function that is also used for the replacing. And these have, however, 3 required arguments. The one is a string, which is to be processed. Second, a regular expression, identify the substring, and the new substring to replace the identified substring. So one is a string, one is a regular expressions, one is a new substring. And in case of the RE find no case, there is no case sensitive. That means whatever the data, whatever the case we have that is required, that is available over here. So whatsoever the data we are using up, whatsoever the file we are using up, that is must be required, that must be used within the database. That is the third and the fourth argument. Whatever, that symbol pattern is different. That is used in the text string format that is given as a second parameter, second argument, required argument. Similarly, for the third and the fourth function that are used for the replacing, so these functions have, however, 3 required arguments. That string which is to be processed, which is available as a regular expressions, identifying the substrings, the new substring to replace the identified substring. And we already discussed about the second regular expression function, that is the refind no case, regex string start return sub expression for passing the text in the agent2.cfm template of the agent2. Example that is given is to identify the wanted keywords in the text of the news. And the syntax for forming regular expression is based on the set of the operators, character classes, and or table operating system interface, that is a POSIX classes. And for a more detailed expressions, we are using for the syntax regular expression consider the RBB. Now, next is revisiting the search engine. So whatever the search engine we carry out, that is used by means of the मैंने कब बोला मैंने नहीं बोला नहीं अभी सीधा भी पीता ही अच्छा by use of the software we use, that is the module, it is used in the word fusion, and one of the verify functions for indexing. लाइट चलाते हैं यहाँ पे दो स्विच बीच वाले. So that will be used for the passing, identifying and marking the each word of the document, building a frequency list, each containing data, each containing different arguments, different words that are appearing in the document. And when used as a passing of the document, that is completed out, so there's a word frequency list for the whole collection has been generated. And for each recorded word, links have been established to all the documents in which the word occurs. This is a more text. Read a text, read a word, new word, end of the file. If there's a new word, then yes, or the no, then update, then more text. If there's again more to read a text, again to more to read a update. Yes, no, end of the file. So these are the logical diagram for the indexing process. And the result will be an inverted index of words, each with the frequency of occurrence in the document collection. And whatever the document that contains requested word, that can easily be identified, that can easily be used over here to make the connection, to make the database empty. So whatsoever the database we are using up, whatsoever the file we are using up, that is used in the local frequency in a document. And this local frequency may be used, may be not be used to gather the data within the database. And in the following example, we demonstrate this diagram. This example demonstrates how to construct a template which reads a text file, parses the text by means of a regular expression, and builds an inverted word index for the document. Yeah, making a regular expressions, builds on regular expressions, inverted down the regular expressions for the document. And to make the demonstration complete, the application have an introductory form by means of which you can upload your own text files. And the second template, parse.cfm, also uploads, parse, and prints the results from the specified file. So whatsoever the files, whatsoever the data we are using now, that must be required, that must be used in the introductory, that must be used in the CFM files. Now next is the index.cfm. So H3 font color is given as a blue, text file indexing, font will be closed, H3 will be closed. In CF form, action is given as a parcel.cfm, method is given as a post. Then name of file, input type is given as a file, name is given as a file name. Then type is the submit and the value is the submit button. This is used to specify a text file at the client computer for uploading the server to the processor. The next step is to search sequentially through the text to the document string in the file to identify each separate word, record the identified word in a list, and if not exist already, or increment a frequency counter encounter if it exists, and repeat the next word. And for each existing words, its frequency counter is also incremented by the 1. And when all the document is established, is exhausted, that is done. So words are sorted in the descending order. So first of all, it identified it is used in ascending order, then it is used in the descending order with the order with the most frequent on the top of the list. Yes, this is the example that is used as a parcel.cfm that specifies the index.cfm is uploaded that reads into the variable file up as a string value, its characters counted. And the core of the process is surrounded by the two pairs of the CF loops. We are either using the nested loop, we are either using the while loop. And the first starting at the line 8 and the closing at line 26 is transferred as many as time it is used to process the identified words. And the second and closing lines, it traverses for each characters in the words. And whatever the core planning, whatever the data we are using up, that is used to process the start by finding each and every word. This is done by the line 9 in which the position of the end delimiter of the word count is identified. And since it is the beginning of the character that is following the end delimiter of the previous word, so this can be also be extracted by the tag of the line 10. So whatever the position of the delimiter that is following up, that is used in the current word by means of the function refind no case. So this is the refind no case. No case means either using the uppercase, lowercase, that does not matter. So this delimiter will be processed as a regular expression of the first argument. This will be discussed. And in this template, we are going to use the two postfix classes. One is a punctuate, one is a space, so that it will be identified, it will be used, or it will be gather the information in the postfix function. So that bracket must be separated, that bracket must be enclosed, that must be repeated to be correctly interpreted. And the first class matches most punctuations character that not appearing as a data, not appearing as a file, and the second class matches the spaces. So whatsoever the file it is using up, that same result could be obtained by a regular expression that should be given that based on the character result. And when we use a position, that argument needs Abhi, that argument must be needed from the string MID. Now the next part is given as an end delimiter that is used for the processing that starts by finding each and every word. And since the beginning of each word is given by the end of the delimiter, that is of the previous word, so the same can be extracted by the tag that is given. So we are using refind no case in which the criteria for finding the next word delimiter is a regular expression appearing as a first argument. And in this template, two postfix classes, that is a func and the space, are used. And note that in the function, the square bracket must be repeated that to be correctly interpreted. And the first class matches most punctuation character that not appearing as a part of the English word. So whatever the data, whatever the word that is used, that will be used as a part that will be used as a part of the English word. And the second class matches the space. And as indicated, the same result could also be obtained by the regular expression that is based on the character classes. And with the position at the end of the word, the start position of the word that is given with the three arguments needed for the string function. One is a mid function, then the line 10 that extracts the word as a variable, and these lines 11 to 20 determine if the current word already in the frequency list. So whatsoever the data, whatsoever the word that is recorded out, that will be given as extracted and tested against the list of the words. Now, this is the one of the coding. This is the past parcel.cfm. The CF file action is upload. File field is file up. Destination is a path file up txt. Name conflict is the overside. Then CF file action is a read. File is path file up.txt. Variable is a file up. CF set document size length file up. Then CF set start is 1. In the same way, frequency structure is given as a struct new. Then CF set characters proceed or process 0. Then condition is given as a character process LT document size. and this position or condition will be given, or this will be given as a condition. So this is the character process less than document size, and position is re find no case one space file of start. Then the word is the mid of the file, that is the file of start position and the start. Then CF set hit is 0 and the counter is again the 0. Then CF loop condition is given as a counter less than struct count frequency structure and hit equals to 0. In the same way, struct key exists, frequency structure word, then struct find frequency structure word, then struct insert frequency structure word frequency, that will be given as a 1 and the 3. So CF set hit is equals to 1 and the CFF will be closed. After the CFF, the CF set counter is a counter plus 1, loop will be closed, and this hit is equals to 0. So the struct insert frequency structure word is 1. So this CF set is given as a frequency structure, that is given as a word, or this is given as a 1.